Okay, good afternoon, everybody. Welcome, welcome on this beautiful November day. We got our dean to arrange the weather just perfectly, and we're so grateful for that. So I'm so excited to welcome you all. I'm David Gertis. I'm the chair of the U of M Physics Department, and Dean Rosie Sabaggio from LSNA is also here to celebrate the unveiling of the sculpture Rotation is Quantized that celebrates Elmer Imes' discovery in 1918 that rotation levels of diatomic molecules shaped like little dumbbells cannot spin at any arbitrary rate. They spin at specific frequencies governed by the rules of this, what was then a newfangled theory called quantum mechanics that was not fully fleshed out at that point. And Imes's discovery was a critical building block of the theory that grew to be quantum mechanics. I'd like to welcome a number of distinguished guests and visitors here today, starting first and foremost with our colleague, Professor Emeritus Jens Zorn, right here. Jens, of course, was our colleague in physics for many years when he was on the faculty, but also has had an incredible career as an artist and sculptor, not only of this work that we're unveiling today, but of these other beautiful works in this courtyard that illustrate other important milestones in the history of this department. And you're welcome in your spare time to peruse these and reflect on them and the place that this is taking among those works. I'd also like to welcome Jens's longtime collaborator, David Crosby, who physically built this thing. David got to know Jens when he was an undergraduate in one of Jens's physics classes many, many years ago, and that's a friendship and partnership that has continued for nearly 60 years. I'd also like to welcome two of our distinguished guests from Fisk University. Fisk is where Elmer Imes went in the years after getting his degree at Michigan. This historically Black university did not have a physics department, and Imes established the physics department at Fisk and went on to create a bit of a pipeline between Fisk and the University of Michigan. And I'd like to welcome Dean of Graduate Studies, Kent Wallace, and and curator and collections manager Christine Gostowski, who is played an important role in putting a copy of this, a twin of this sculpture in a prominent location on the Fisk campus. Welcome, Christine and Kent. 106 years is a long time in science. Quantum mechanics was brand new and kind of uncertain and untested in 1918, and now we carry around the results of quantum mechanics in our pockets. We wear it on our wrists. It's a part of our everyday life, and the world has just moved and built on that discovery that had one of its beginnings right here. 106 years is a long time for societies too, but societies change less rapidly and sometimes more fitfully than the world of science. When you think about the opportunities that were available to Dr. Imes in 1918, they were really quite limited. When you think of the expectations that society had for someone of Imes's background, they were quite modest. And I would like this sculpture to stand as a reminder that at a time when most doors in higher education were closed to Black Americans like Dr. Imes, the University of Michigan's doors were open. And at a time when so many people had conceptions of what a scientist was supposed to look like, and that conception was that they look white and European, that the University of Michigan and Harrison Randall in particular had a different idea and saw the potential and saw the ability of a young Black man from Tennessee. And in this time when we're having a continued polarizing debate in our society about who gets to have access to an elite education, I would also like this to stand in everyone's mind as a beacon and a sentinel that reminds us what can happen when we open our doors and open our arms and open our hearts. So let's celebrate this day, this important day in the life of our department, in the life of our university. And I'd like to now introduce our Dean, Dr. Sabaggio, to make some additional remarks. Thank you.
So thank you so much, David. Those were wonderful opening remarks, and I will have much less to say now, which is good. I thank you for crediting me for the weather. I so wish that Dean Lee powers extended to the weather. They do not, but how important is it for all of us to be here today to celebrate such an important and special event? It's an honor to be here. Thank you for inviting me. I want to say that remembering our history and taking time to acknowledge and celebrate our accomplishments, our legacy, our achievements, those are things that we have to stop and make time to do. I am also incredibly proud that our university, a long time ago and still today, strives to make sure that diverse scholars can succeed and do the work that they are able to do and thrive here at the University of Michigan. I do not look like a dean to many people. So there is some sense of this, the challenges that we face that continue. I don't look like a scientist to some people. And as I learned about Dr. Imes, it's interesting to feel the challenges that he must have faced with the challenges that we still face today. So let me say a little bit about Dr. Imes, because that's what deans do, right? He was the second African American to earn a doctorate in physics from a U.S. university. We are also honoring, as David said, the talents of one of our most beloved emeritus professors, Dr. Yan Zorn. So thank you. A physicist whose unique ability to render important physics discoveries into artistic form has made us better appreciate this department's glorious history. His sculptures have enriched the scope of public art, and now as I walk past here, which I do often, I will have and take with me a much deeper appreciation of their meaning and their importance. Imes's work and his thesis at Michigan established the quantum nature of how molecules rotate. He said that and he understood that. His results were highly influential. I'm not a physicist, so there's probably little that I can understand about the theoretical basis of his work. However, I do want to say this. His discovery helped develop the microwave in my kitchen. I understand its utility, and I appreciate that every day. Okay, 50 years after Dr. Imes graduated from the University of Michigan, another trailblazing U of M physicist, Willie Hobbs Moore, defended her doctoral thesis in our physics department. She became the first African American woman to earn a PhD in physics. She extended Imes's groundbreaking discoveries into the realm of biophysics. And this lineage of academic teaching and mentoring at Michigan is a hallmark of the department's contributions to the development of quantum science. The work continues with the recent formation of the Quantum Research Institute, a joint venture of the Office of the Vice President for Research, the College of LSA, and the College of Engineering. And not only was Dr. Imes a giant force in quantum science, but he and his wife, renowned poet and author Nella Larson, were central figures in the Harlem Renaissance. So it's not surprising, as we've said, that Dr. Imes faced a lot of discrimination in his career and when he went off to establish his academic journey. In 1930, he returned to his alma mater, Fisk University, where he enjoyed a distinguished research career as the founding chair of the physics department and the head of a very prolific spectroscopy research center. There he trained students. There he had students who he sent here to the University of Michigan, who then returned to become faculty at Fisk University. So in this way, the University of Michigan and Fisk University have enjoyed a history of innovation, discovery, and partnership spanning more than 100 years. And I am so delighted that we have representatives from Fisk University with us. A twin sculpture, as was mentioned, to the one we dedicate today is also present on the Fisk University campus. And let me just say, I'm going to end with this. I have never had the privilege of unveiling a sculpture before, and I am so honored that this is, and I told David, I'm short. I don't know how this is going to work. I'm glad that it's not too tall, this sculpture. But I am so honored that my first unveiling of a public sculpture is this one. So thank you all so much.
Okay, and before we do the big reveal, I'd just like to invite you all to join us up in 340 West Hall in a few minutes after this event outdoors concludes. There'll be some further remarks by several people here, followed by refreshments. We have also, thanks to our crack team of demo lab experts, we have set up a working replica of the Imes spectroscopy experiment in the hallway outside 340 West Hall that you can also enjoy. And with that, are you ready?
I can the mic down now. You need two hands, right?
Do I need two hands?
Okay.
So come on in, and indoor festivities will resume in about 15 minutes up in 340 West Hall. So thanks again, everybody. I am David Gertis. I'm the chair of the physics department. I won't reiterate my welcoming remarks that I just made outdoors to our friends and visitors, but I do want to say that this day has been a very long time coming. And I will not rehash the ups and downs that we have been through with our central administration to get to the point where we could install this sculpture outdoors, but it's been a very long road. And there are a few people who've played a really critical role in making this happen through their persistence and unwillingness to give up and their allyship with this effort. And no one more so than Roy Clark, who's really been pushing this for years. I also want to acknowledge the hard work and dedication of several other people, including Charlie and Kordak, and Leo Pandozayas, and Jennifer Ogilvie, as well as a couple of generations of our DEI graduate student staff assistants, especially Gabriela Garcia Martins and Cynthia Nunez, who really played a very important role in keeping this in front of the eyeballs of the central administration until they finally broke down and let this happen. So thank you all for you. So I'd like to just briefly reflect a little more on the significance of Imes's accomplishments, and to appreciate that, I'd like us to go back to his roots and go back in time to Memphis, Tennessee in 1883, the year that Elmer Imes was born. It was just 18 years after the Civil War. His father, Benjamin Imes, was a minister and a graduate of Oberlin College in Ohio who'd been born free in Pennsylvania to a family that had been free blacks since the time of the American Revolution. Imes's mother, Elizabeth Wallace, had been born into slavery and moved to Ohio after the war. Memphis had a large African-American population, the majority of whom were formerly enslaved people or their direct descendants. The 1880 census showed that over 60% of the black population in Shelby County had been born into slavery. Many of these individuals would have been in their 40s, 50s, and 60s during Imes's childhood, meaning that he would have grown up surrounded by firsthand accounts of slavery and emancipation. This was also the period of the collapse of Reconstruction. Imes's childhood coincided with the descent
of segregation across Tennessee and the South. His early years witnessed the passage of the first Jim Crow segregation laws, the disenfranchisement of black voters through poll taxes, literacy tests, and intimidation, the establishment of segregated schools and public facilities, all of which, of course, were deeply inferior. Yet Imes' family background did place him in an unusual and relatively privileged position within this landscape. As the son of two college-educated parents, he grew up in what W.B. Du Bois would later call the talented 10th, a small, tenacious black middle class of teachers, ministers, and professionals. This background provided him with educational opportunities that were exceedingly rare for African Americans of his generation, even as he and his community experienced the cruel realities of the Jim Crow South. These enormous structural barriers persisted throughout Elmer Imes' life. In 1918, when he earned his PhD in physics, only around 1% of African Americans held college degrees of any kind. The landscape of higher education was marked by systematic exclusion. Many institutions explicitly barred black students from admission. Most African American students pursuing higher education attended historically black colleges and universities, which lacked the research facilities and funding available to their predominantly white counterparts. Very few of them offered a physics curriculum at all, and Fisk was one of those institutions, Imes' undergrad institution, that at the time did not. Imes' work demonstrated not only exceptional academic capability, but also extraordinary persistence in the face of lifelong systemic barriers. Today, we recognize not only Dr. Imes' scientific contributions, but also his role as a pioneer for future generations of African American physicists, including our own Homer Neal and Willie Hobbs Moore. Dr. Imes' story reminds us that scientific talent knows no racial bounds, that our field is enriched when we remove barriers to participation and create truly inclusive spaces for scientific inquiry. It's a battle that must be fought in every generation because it can still be lost. Thank you. Isis, I believe you are next, so it's my pleasure to welcome to the podium Dr. Isis Settles, the Associate Dean for Diversity, Equity, Inclusion in the College of LS&A. Take it away, Isis.
Thank you, everyone. I am just getting over laryngitis, so I have my water here just in case, and cough drops in my pocket. But I am very delighted to be here. Thank you for inviting me to come and just say a few remarks. As David said, I'm the Associate Dean for Diversity, Equity, Inclusion in the College of LSA, and I'm also a faculty member in the Department of Psychology. I'm really delighted to be here to celebrate the dedication of Jens Zorn and his collaborator, David Crosby's statue that honors Dr. Elmer Imes' landmark discovery. So part of what I do is I oversee some of the college's DEI efforts, and U of M has had a long-standing commitment to DEI that is happened both formally and informally. So informally, the physics department is a great example of that. We have been embracing DEI for 100 plus years. More formally, of course, our DEI efforts are seen in our institutional DEI plans that began in 2016. So I'm really proud of the efforts that we see in the college. So just to repeat a couple of things that folks have already said, it's really impressive, I think, that Dr. Imes received his undergraduate degree in 1903 at Fisk, came here to become only the second African American to earn a PhD in physics. Then I think, notably that he did face quite a bit of discrimination in academia, and so worked as a scientist and a consultant in industry for a number of years before returning to Fisk University, where, as David said earlier, he became the founding chair of the physics department. One of the things that I really love that we heard earlier is that pipeline partnership between Fisk and the University of Michigan. So I think the dean mentioned that several of his students came to University of Michigan for their training and then returned to Fisk as faculty. And so that's a fantastic example of a really important kind of pipeline program. And so I think, thinking about both this sculpture and the legacy of Dr. Imes, there are a couple of really key things that stood out to me. Representation matters. So it changes who can see themselves as scientists. It also changes how society thinks about who can be a scientist. These pipelines are critical. There are partnerships between different scholars, between different universities, between communities, are really critical ways in which we continue to diversify some of the fields where diversity is more lacking. And I just met some of the students, where did he go? Somewhere, from the National Society of Black Physicists, so the chapter is here. And I learned and love that they're named after Willie Hobbs Moore, recognizing that first African-American woman to get her PhD in physics, again, here. So that's a wonderful example of both the kind of early pipelines between the University of Michigan and Fisk, and then a kind of continued pipeline of generations. So early scholars really producing later scholars that really continue on, and the importance of those relationships in building a diverse scientific landscape. So representation doesn't only matter for who is here, but also it matters for scientific discovery. We know that talent and ability are found everywhere, but access is not equally distributed. I'm really glad that the U of M Physics Department has been able to see that for quite a number of years, 100 plus years, and has been open to seeing excellence and talent wherever it resides. I'm grateful for the discoveries that Dr. Imes produced, and Dean Ceballo mentioned the microwave oven. So as a non-physicist, I also appreciate that one. And I'm sure there are many other things that are important discoveries that physicists understand and appreciate, but also that we lay people probably appreciate and don't know that we should be attributing to him. So, kind of jumping around here. I just want to reiterate the thanks that Dean Ceballo mentioned for our Fisk colleagues being here today, Christine Gostowski and Bryant Wallace here. I think it's really important to have these connections, and I love the idea of the twin sculptures. I almost envision them as like portals, or some ways that people could kind of connect and talk to each other. So I think that's really lovely. So, one thing I found online is that in his obituary that Dr. Imes was described as having a poetic disposition, being widely read in literature, and being an ardent appreciator of music. And I really believe that a scientist who has a love of the arts would be especially delighted to see his work depicted through the beautiful sculpture that we saw outside, and for the twin sculptures to be located at the two institutions that really, I imagine, meant a great deal to him. So just thank you all for being here today to celebrate the remarkable contributions to science, to education and the arts. I also love that connection between science and the arts. They really do go hand in hand, and so this is a great example of this. And I'm really confident that the legacy of Dr. Elmer S. Imes will continue through kind of the partnership and collaboration here at the University of Michigan and through the partnership with Fisk University. So thank you again for allowing me to say a few words.
Well, wow. You can't believe how much I look forward to this day. So thank you all for coming and helping us celebrate this really happy occasion. I want to welcome two of our guests of honor who were absolutely critical in the process leading up to today's dedication ceremony. Two guests of honor from Fisk University in Nashville. First, I want to recognize Christine Gostowski, who who is the registrar and manager of collections at the Fisk University Art Galleries. Christine's unbounded enthusiasm really propelled the idea of a twin placement of Jens's wonderful statue on both campuses of Fisk University, Elmer Imes' undergraduate alma mater, and here at the University of Michigan. And I have extremely happy memories of the event that was hosted at Fisk a year ago, October, because it was their special Jubilee Day at the university. And for those of you who may not know this, the Jubilee Singers of Fisk University have a worldwide reputation in music, and have given concerts now for over, 150 years, including in front of Queen Victoria. So that concert that evening that we went to, I will never forget. And that was a very special part of the celebration at Fisk University. So Elmer Imes did his groundbreaking research with Harrison Randall here between 1915 and 1919. It was a very special time in the development of quantum mechanics for our field. Imes' work was a spectacular leap forward because what it did, it propelled the nascent quantum theory of the time from just looking simply at isolated atoms and the electronic states in those atoms, propelling it forward into the situation where molecules are formed and the quantum states of those molecules. Elmer Imes played a huge role in showing that they were also quantized in terms of the vibrational aspects of the molecular structure and also the rotation of the molecule. So those were very, very profound findings that he did in it as a graduate student and in the experimental field of molecular spectroscopy, infrared spectroscopy. So I want to recognize Christine and her husband Rudy, who's a faculty member and a collaborator. I want to thank them for championing the cause of science through public art. So please give it up for Christine. That is a wonderful connection between science and art, which we cherish. Now I'd like to introduce Kent Wallace, Dean of Graduate Studies at Fisk University, Director of the Physics Laboratories, and Treasurer of the National Society of Black Physicists. I will be going down to Houston next week to join Kent at the annual meeting of the National Society. This year it's in Houston, which is very significant because Kent is very famous for his work with teams of students on NASA-supported projects to reach the upper atmosphere and to make studies through radio sondes that are launched from the ground. And Kent has made a name for himself, and he's even received the magnificent title of Professor of Rocketry. Are you the only? You're the only person I know with that title. So let's give a warm welcome. And by the way, if he tells you it's not rocket science, then, you know, for him, it really is. So let's
Thank you.
A warm welcome.
Thank you so much. Thank you. I promise to be brief, and I can't help but use my time properly by acknowledging my appreciation of Dr. Clark and my colleague Christine Gostowski, because without their efforts, this moment would not have come to fruition in kind of bridging the gap between the scientific side of the representation of the art and the artistic side and the actual implementation of the art, which is a thing unto itself. Obviously, the family and Dr. Zorn, we weren't able to be at Fisk, and the family came, and it was just really a wonderful experience, and I want to just acknowledge how much we at Fisk University appreciate you. And obviously our friend physicist engineer that, let me put it like this. He has a unique ability to have me laugh at myself without being insulted. But no, nevertheless, it's just been a wonderful set of experiences. And so what I really wanted to use my time to just say is, and I'm a person that I'm the one that always has the difficult conversation. And I want you to know that I love my students at Fisk, but I think you can appreciate the fact that I now have students at Fisk that are scared. They're proud, they're scared because depending on where you stand on the side of recent events, they don't know what things are about to happen. And I have to admit, I shared their sentiment. But then once I landed here and it started to really hit what was about to happen with this ceremony, I was heartened. And what I was heartened is, when you look at the history of what has happened, how poignant is it that there is a symbol that is represented on both of our campuses, that University of Michigan and Fisk have had a relationship that helps students through the headwinds of adversity. It's not only symbolic, but it's physical. You can see it, and in the days ahead, you can point to it. That shows that as long as we have people that collectively believe in the diversity and the group of the participation of all people in the areas of science, great things can happen. I can't tell you how proud I am to represent the legacy of the second black to get a PhD in physics, who was the founding chair of our department, and to stand in that legacy, it puts a duty on my shoulders to not only let it down, to not only let rest on a reputation, but to take that reputation to new accomplishments of the future and to be a part of that. And you should know, there is one statue on our campus that has existed, and it was of W.E.B. Du Bois, the inventor or the founder of sociology. This sculpture is only the second sculpture to be publicly displayed on our campus, which should point out the significance of its importance and how proud I am to have been a part of this partnership. So let me just close in saying, this sculpture rather, being dedicated, is not the end. It's the end of the beginning. And now we live up to its symbology of our connection between our two universities. I always, scientists recognize patterns. And what I noticed when I decided of what to wear today, and I put on my suit and tie, someone went and said, "I noticed you're wearing our school colors." And I was proud to say, those are Fisk colors. And we are connected in ways that you don't always imagine. So tomorrow, or any day that you pass that sculpture, give a thought to the students who have come to us, who came to you, and you help them on their journey of becoming scientists and engineers. And think of us back at Fisk who will be sending you more. We don't send our students into hostile environments. We don't send our students into places where they're set up for failure. We seek places where there are like-minded people, where they will challenge our students, not just, oh, you poor student, you. No. We want someone who is going to challenge them and prepare them for the world that they face and to make their own set of discoveries and accomplishments. And just sitting here looking you in the eyes and seeing the students that you have now, I cannot express to you in words how proud I am to represent Fisk, how proud I am to represent the National Society of Black Physicists, and just simply to be an educator, to provide an opportunity for students to take us from where we are to what we can be. Thank you.
I'm Çağlayan Kurdak. I'm the director of the Applied Physics program, and we have ties to Fisk in ways you may not recognize. I think it was 2009. I was the grad chair in physics department, and Abby Stewart, one of my colleagues, wanted to meet with me, and the meeting was about a master's program at Fisk, and she said, Çağlayan, you really have to look into this thing. They are doing great things and you need to know about it. And of course, I took that seriously, and I attended a meeting in Washington with APS, where I met some of the people from Fisk and other. And it was very influential in our Imes Moore Fellowship, which we started in 2010 with Roy and John Foster and Rachel and Duncan and many of my colleagues. And we were inspired by the work they were doing. And we talked about this pipeline between Fisk and Michigan, and whenever I see an applicant from Fisk, I get excited. I read it carefully, and the most recently, Erin, who's in the audience, who applied to our program from Fisk, and you know, you read the application and you want to know who this person is, and in her case, she talked about things like climate and things that sort of showed her passion, and we were excited, and we are so thrilled when we were able to recruit her, and she's still active in policy area in addition to doing wonderful research in nuclear engineering. We meet our colleagues at the National Society of Black Physicists conferences. I've been going to these conferences every year since 2010. It's sort of energizing, and I want to let everyone know that in 2026 we will be hosting the NSBP conference here at the University of Michigan, and this will be an effort that is welcomed by our students who have recently formed a chapter. Jayla was the first president, and she was present at the Fisk event, the similar event, which I was not able to attend. But we have Chris Ayala with us, who's the current president of the NSBP chapter, who's going to say a few words.
Hello, everyone. Good afternoon. My name is Christopher Ayala, and I have the honor of serving as the second president of the National Society of Black Physicists Willie Hobb Moore chapter here at the University of Michigan. My research focuses on the generation of high harmonics in semiconductor materials, and I want to start off by saying that as a chapter, we definitely recognize that in the field of physics, black and brown people are underrepresented, that the goal of our organization here is to expand this community at the University of Michigan, as well as create a space where the black physicists, as well as their allies, can grow and just feel safe in this environment, especially in the current climate that we exist in. I would like to say that as an Imes Moore Bridge Fellow, that it's not lost on me that I get to stand upon the shoulders of the giants that have preceded me, including Elmer S. Imes, Willie Hobbs Moore, and even Homer A. Neal, whose got a recent building dedication to his name. Imes, as was expressed many times in today's talks, that he really started a legacy here at the University of Michigan that we continue to try to strive and aim to better ourselves. David gave a quote / statistic earlier that at his point in time there was maybe 1% of black physicists in the country, or 1% of black people had a higher degree. But it's really warming, like Ken said, to see that as of recently, the applied physics program has put out 25 to 28% of black physicists in the US, which is a giant leap in bounds due to different adversities that we face. And lastly, I just wanted to thank everyone for attending today's ceremony, and where we are able to celebrate and honor a man who has pushed through the adversity of the early 1900s to show us that a future where black physicists thrive does exist. And I also want to share in the sentiment that we are so happy to be hosting the 2026 National Society of Black Physicists National Conference in tandem with the National Society of Hispanic Physicists, two communities that, again, are underrepresented, but get to have a place here at the University of Michigan where we are always trying to, do better as well as show up and show out. Thank you very much for listening, and have a good rest of your day.
Good afternoon. My name is Leo Bandosayas. I'm a professor of physics here. I'm also the chair of the DI committee. The DI committee is a little bit like a lab where many of these initiatives are first born and they grow. They grow, of course, through the work of many, many people who are committed to certain principles and dedicate their time. So one of the persons who has been an example for all of us, and for me in particular, very personally, is Jennifer. So I'm here to introduce her as her new speaker. So Jennifer did her undergraduate studies at the University of Waterloo, and then got her PhD from the University of Toronto. And after a postdoc at École Polytechnique, she came to us in 2005 and went up through the ranks until 2024, when she moved to Ottawa to become also a professor there, but she maintains a connection with Michigan as an adjunct research assistant precisely for the Quantum Research Initiative. So things come around, as you can see. As I said, again, and you have heard from many of the speakers, so there's a institutional commitment to diversity that is very strong in Michigan, but I want to emphasize that that commitment really lives in the people who are doing the work. Jennifer, together with many other colleagues in the DI committee, also including David, who has been very supportive throughout, the chair of the physics department, Chalian and Roy, they were able to make the case to the President's Advisory Committee on Public Art to actually get the sculpture displayed. So without further ado, I invite Jennifer to make some remarks.
So I'm just so delighted to have been able to join in the celebration today. Thanks so much for the invitation. And I promise not to show too many slides, but I really have the honor of, I wanted to just say a few words about the magnitude of Imes' discovery and just share a little bit about his work. And I definitely encourage you to please take advantage of the wonderful demonstrations that the demo lab, Monica and Roy in the demo lab have put together outside. I'd also encourage you to read the article that was written that Elmer Imes wrote summarizing his doctoral work. He does a wonderful job in the article of setting the stage where the thinking was at the time. So quantum theory was very new, and it wasn't obvious to what degree it applied. And so in the introduction of his paper, he really sets the stage. So he talks about how in 1904, Drude had proposed that the infrared absorption and emission had a vibrational origin. And in 1911, Nernst noted that likely quantum theory would also apply to rotation. Okay. Also in 1912, Niels, not sure how to say this, Jerem, he proposed that if one had an oscillator vibrating at a frequency nu naught, rotating about an axis, that if that rotation had a frequency nu sub r, that one would likely see new frequencies that were linear combinations of the vibrational and rotational frequency. So in come the spectroscopists. And so when Imes was first thinking about a doctoral project, there was some data out there. And I wanted to show some of the work here of Eva von Baar, who is, her work is cited in Imes's doctoral thesis and in his paper. And he notes that, so prior to her work, the spectrum could give evidence of this combination of frequencies, omega naught plus and minus the rotational frequency. But there wasn't much fine structure that really could be seen. Then in Eva von Baar's work, she could see a hint of the finer structure. So along came Harrison and Imes, and with this very clever spectrometer. So at the time, most measurements had been made with sort of half of this device, using a prism to disperse different frequencies to be able to record absorption spectra. And so what was really clever about this design, so here's the light source here. It's basically a double spectrometer. So one uses initially a prism that was made of rock salt. But then what really provided the additional spectral resolution was the addition of a grating. And there were several different gratings with different groove densities that Imes used to record his data. And I'll show you a few of his beautiful spectra. So this one was taken of hydrogen chloride. So he realized that to truly understand the rotational structure, if it was there, one should start with diatomic molecules. And so he studied a number of them, HCl, HBr, for example. So this is his beautiful data with gorgeous spectral resolution, really showing the beautiful rotational structure in the absorption spectrum. He also saw the overtone, that one could see the rotational degrees of freedom there as well. And this was actually taken with the highest resolution setting on the spectrometer. And indeed, although he doesn't note this in the paper, this fine structure here is actually can be attributed to different isotopes of chlorine. So the data doesn't lie. I wanted to mention too that he was able to extract really a huge amount of information from these spectra. So looking at the different frequencies, he was able to find a quadratic dependence on a quantum number. And once the Schrödinger equation was solved for a diatomic molecule, this was confirmed indeed to be the case. And so he was able to deduce this empirically from his data. He was also able to extract the bond length of these different diatomic molecules. I also wanted to mention, we've got a rich history of spectroscopy here at U of M. And so Willie Hubbs Moore, who's been mentioned a few times today, did her doctorate work here using a combination of infrared and also Raman spectroscopy. So Raman spectroscopy, one can think of this as inelastic scattering, where indeed the vibrational quanta play a role here as well. So she also did normal mode calculations and was able to describe both the infrared and the Raman spectra of a number of different molecules. And just to finish, I wanted to say just a few words about the importance of IR spectroscopy today. So today it's such a common tool. It's used in drug discovery. There are IR microscopes that are used. So lots of biochemical applications. I've used it myself in my own research here in the Homer Neal lab, where in fact I was able to use it in order to try to understand how the primary events of photosynthesis occur, how the initial absorption of light energy is converted to separated charge inside something called a photosynthetic reaction center. And the shifts in the vibrational frequencies of the neighboring protein were able to help me figure out the mechanism of this particular reaction center. And of course, a beautiful example, we've all been wowed by the images of the James Webb telescope. So from what I understand, there are 4 different instruments that have a number of different imaging modes, looking in the far infrared and mid-infrared for just huge questions about the early universe, using the frequency shifts and the frequencies themselves to learn about atmospheres of exoplanets, all kinds of deep, deep questions. And with that, I'd like to thank all of you. It's wonderful to join this celebration.
I'm Eric Zorn. Jens Zorn is my father. In the late 1990s, when he was older than I am now, and I'm old, an interesting and sad set of circumstances launched an amazing second career for him. Arthur Rich, his friend and colleague here at the physics department, had died at the age of 52 of a brain tumor, and his family had commissioned a sculptor to create a small campus monument in his memory. The result was fairly abstract. It's out in front of Randall, and took a look at it. And the family felt that it didn't really reflect Art's life and career in any special way. He'd been a specialist in subatomic particles and was the co-inventor of the positron transmission microscope. He also led a group of scientists in developing the use of positron beams to explore the chemical origins of life. So my father stepped in, and despite his lack of experience as an artist, he took on the task of designing a sculpture that represented Art Rich's life's work, with graceful arcs of copper that, as he wrote, references the mutual orbiting and ultimate annihilation of the electron-positron pair that comprise the positronium atom. The result truly, uniquely, and symbolically commemorated Rich's scientific contributions, and you can see it out in the courtyard where we just dedicated the Imes sculpture. It also spurred Jens to begin creating more highly personalized, abstract scientific memorial sculptures that relate directly to groundbreaking work, such as the work we're honoring today and the other works that are out in the courtyard. These beautiful and intriguing creations are now installed at more than half a dozen other universities and institutions around the country, and at so many spots on this campus that I'm told the art school is getting jealous. He's had a lot of help from friends and colleagues in the machine shop and from university officials who've recognized the value of highlighting the important work that their faculty has done. One person in particular that needs to be singled out is David Crosby, sitting next to Jens here, our family friend, former UM physics grad student and fabricator and co-designer of this and other works. Our family is amazed and proud of Jens's singular accomplishments and thrilled that he's continuing to be engaged in this work at the age of 93. His reinvention after a long and rewarding career as a scholar and administrator should inspire us all. Thanks for coming. I'd like to introduce David Crosby and Jens Zorn. Is there a microphone here that you guys can use?
Well, I don't know.
Is there a
Do we have a
portable
microphone we
microphone?
can get to Jens? And let me see if I can find slides. Is Carol here? Where did she hide the slides?
Is this working?
Yes.
I want to ask the question why we have commemorative sculptures on campus. Sculpture can remind us of the past in ways that set a standard for future accomplishments. Sculpture can express our appreciation of individuals whose actions, achievements, and creations have brought honor and distinction to the university. And, as in our case here, to recognize the discoveries of Elmer Imes. Sculpture can help our future growth, also the growth of the university. Let's be clear, universities today are an increasingly competitive environment. We in Michigan don't seem to be lacking for money to spend on things. That is by far an unusual situation for educational institutions across the United States. So we need to attract the best people. We need to convince the visitors, whether they're prospective students, potential faculty members, or likely donors, that this university matters. A brighter world awaits. Join us in building the future. If you want to make a difference, join us here in Ann Arbor. As is true for the sculptures that are already in the courtyard, rotation is quantized, reminds us of what we have done. It brings them to imaginative view to what we might achieve. And it is not about the artist. It's about the person being celebrated in the achievement. This is a contrast, of course, to other collections of sculptures which are representations of artistic views that are quite different. I wanted to stand aside, give you just a second to recognize that this sculpture was designed by Whitby Ewer, which is a function of artist with architect Ewers. Also, by way of size, we are missing the I'm trying to think of a historian who's at Clark University in Georgia, Rome Mickens. Yes, thank you. Sometimes there is a specific goal for the sculptor to work on a piece. Sometimes it seems to emerge from the materials, the creative process. I have been fortunate in having an office which is right across from the machine shop. And I can just sort of walk by the scrap pile and say, do you want this out there? And one representation of something like that is here. This was these are pieces salvaged by the Bronx from the decommissioning of the positron microscope in Harkovich, and Bill Phillips being given one. And then we converted that to styrofoam Because in ski is a battle of gets too heavy and gets too dangerous. So we experiment, big, cut this out,
etc. Keep talking.
So this is the way we're going to experiment. The thin message violate the beach of location and experiment installing it outside without significant expenditure of time and money. In the beginning, I was doing most of this looking myself, but I soon found that if you're not easy, art it's appreciated for its aesthetics, you don't want me to read your well-in court. And so I enjoyed the collaboration of people, including in our own machine shop with Dave Carter, Jim Tice, and Josh Blackman in sheet metal shop, and of course most recently Dave DeCosmo. The collaboration with Dave, of course, is in sculptural things is fairly recent, but we were doing experiments on atomic physics back in the 1960s when I was still reading experiment outputs on the Beer galvanometer, which is a device most people don't use anymore. Let me conclude by saying that working in this way has been an enormous privilege. I can't think of a better way to have been supported than has happened to me. Well, thank you very much. Good presentation. Aqui, olha aí as músicas, filho. First one is the positron annihilation.
It's not my computer.
We should just scroll through and.
Well, that might be harder when you think. Okay, there's part of proceed, so.
This is the courtyard, the storage structures here. The interesting one,
What's?
Yeah,
Okay, there's positron. What's the next?
This is a representation of the ammonia molecule. It is a direct descendant of the Imes experiment. It's a high resolution examination. What happens when you look at the ammonia molecule carefully, the nitrogen, the center, heavy and large, oscillates back and forth across the plane and satisfy the nitrogen. And you have what you can use as a pendulum for atomic clock. That was built first by a U of M graduate in the National Geostatics in 1948. That sculpture is the other man. Then there's Bellhung's the Nobel Prize.
I vote.
And of course there's the G-2 representation, which is interesting as a observed as sole procession of the novelist metaphor in the 1950s. And immediately there are people who said this was a turn cap mean what it says it says, because the uncertainty principle would rule it out. But G-2 is the key, and the key continues with people who are on family, Jim Chuck and others. different party you on, and then more means. So there's a lot more we could do. There's the bubble chamber is not in where we celebrated. Optical harmonics did not be celebrated. Going a bit further afield, there's side-looking radars, which were labeled topographic maps to be made in the entire country in an afternoon by a single airway flight over. So the list can go on. Stark Salk's polio vaccine was announced here, and everybody knows about that, you know. So we have lots of projects for the future, which will be, I have carried on the lines. Thank you very much.